Okay, thank you. So yeah, I'm Neil Massey. As Alison said, I work on like facilitating data storage for users of JASMIN, I'd say. So trying to writing systems that provide a user-friendly way of interacting with large data storage systems that we have available to JASMIN. So today I'm going to talk about the Nearline Data Store, which is a service we've been working on for a number of years. And this is designed for JASMIN users so that we can bridge the gap between disk and tape and provide a more dynamic and effective way of using tape in JASMIN users' workflows. So, So quick overview, I'll talk about current tape systems that some of you may have used on JASMIN, the Nearline Data Store from its architecture point of view, and then the Nearline Data Store as a user, and then some conclusions and next steps. So for tape in 2025, because some people might think of tape as being old-fashioned, but it retains relevance, and in the next few years, I think that relevance will grow. So as we all know that the data volumes are increasing that we work with, and that's due to the increasing resolution of climate models and the satellite instruments and so on, and also the number of experiments that we do with these models or instruments or the measurements we take are also increasing. But at the same time as this data volume increasing, there's a pressure to reduce energy usage, both from a cost point of view and also from a net zero climate point of view. So this is why tape retains its relevance, and because it offers a solution to some of these problems, is that it's cheaper per terabyte than disk to purchase and run, because as it uses less energy, especially when it's dormant. It's not maintaining a spinning disk when that data's not being accessed. It's just squirreled away on a tape that sits in a tape caddy waiting to be accessed by the tape robot. There's less e-waste on decommissioning tapes, but it is more difficult to use than a spinning disk. And for users' workflows to be effective on JASMIN, then it requires a user-friendly interface. And we've tried in the past to provide this on JASMIN and as part of CEDAR. And we currently have 3 tape systems that that are available to JASMIN users. So there's the Nearline Archive, which is for CEDAR archive data that is too large to store on disk, and that is read-only. And then there's the Elastic Tape, which is the kind of original group workspace tape system, and allows group workspace managers to ingest data from group workspaces to tape. And then the JDMA, which has been operational for, I think, about 6 or 7 years. This was our first attempt at a user-friendly wrapper on top of Elastic Tape that provides the functions of Elastic Tape, but it's easier to use, and also provides some extra functionality such as cataloging and allowing migrations and reporting the status of jobs. So NLDS is designed to replace both ET and JDMA, and so there's numerous problems with Elastic Tape. Then one of the main ones is it's only available to group workspace managers and their deputies. So users within the group workspace can't use it. They have to be approved and added as a manager of that group workspace before they can use the ET. And it has a direct interaction with the tape. The users are directly interacting, and this can lead to contention, being in a queue for a long time, waiting for the tape to become available. And also ingest errors. I mean, elastic tape has a lot of rules about what can be ingested. So like things like symbolic links can't be, and users will get these errors, and the error messages aren't always very explanatory. And one of the main problems is that only one version of a file can be stored in ET. And by a file, I mean a file that has a file path. So, you know, /GWS, /NoPW, /J04, etc., all up to your group workspace. There can only be one reference to that file path in the entire elastic tape database. And so that precludes any iterative backup. You can't change that file and then back it up again. Another problem is that it can be difficult to monitor progress of a job. It's only viewable via a website, and that website is not always available. It's firewalled, so it's not available externally. The data into ET is catalogued, but it's not searchable, and again, you can only view it via the website. The data retrieval is synchronous, and most people who've used ET will have had a retrieval job cancelled when the connection drops. And when that happens, the whole retrieval has to be started again. There's no authentication or authorization. You can spoof a user on ET and access their data. And there's no way to check quota without using the website again. So JDMA was a wrapper for elastic tape, aiming to make it more user-friendly, but it inherits all of elastic tape's problems and then adds some of its own. One of the main problems is this directory locking that you might have encountered if you've used it. And that's where it locks it. You give it a directory to migrate or put onto tape, and it locks it. It makes it not readable by the user until it's finished doing the migration. But if the migration fails, then the directory retains its lock status. And yeah, it's a whole that's been quite a big headache over the past 6 years. The cataloging system is an improvement over ET, but we now have 2 catalogs of the user's data, one in elastic tape and one in JDMA. And we've been very lucky that there's been no syncing errors between those during operation, but there still remains the possibility that there could be a syncing error between those 2 catalogs. And there's still no authentication, and it's still only for GWS managers. And historically, it's had quite poor performance due to a verification step. I modified this about 2 years ago, I think, which improved the performance drastically. But it can still be a bit slow. You're still waiting for it to write to tape. There's the contention that elastic tape has. So to overcome these problems and encourage users to use tape more effectively, we've been developing the nearline data store for, well, probably the past 4 years. It's been a big undertaking. It's a hierarchical file management system, and this means that users can ingest files from what we call hot storage, and that's the disk, to something we're terming warm storage, which is a S3 object store. Some of you may have used the object store in another capacity. So the big idea of it is that you have your disk, your Quobyte or PanFS disk on JASMIN, and you ingest it into the NLDS, and it goes to the object store first, and then it's backed up to tape. So the copying to the object store is much more quick than it is to copy from disk to tape. And the data is cataloged on ingest. So we have a data catalog again, but we only have one data catalog this time. Data is automatically backed up to what we're calling cold storage, which is the tape. Because the object store might fill up the warm storage, the data might be removed from the object store, but remember, it's all been backed up to tape already. And that's via some policies which will be based on things like, if it's a big file and it hasn't been accessed for a long time, then it will be removed. Small files will probably stay on the object store because they're not really taking up much room, and it takes a long time to get those back from tape for the size of them. And there might be other policies defined eventually, but the main policy will be it's a big file and it hasn't been accessed for a long time. So when you want to retrieve your data, you just say, I want to get it from the NLDS. It's the same command. And the only difference you'll see is that if it has to fetch it from tape, then the time lag will be more than if it has to fetch it from the object store. So both the ingest and the retrieval are asynchronous. You can run many retrievals and many ingests at the same time. They won't be cancelled if you hang up your terminal, or like with the elastic tape. And I've put this at the bottom. We don't transform the data when we store it. We transform it as the file format that you put it in. It might be tarred when it goes to tape if it's a collection of small files, but when it's unpacked from the tape to the object store, it is returned to its original format. So people might have used things like ZAR, where there is definitely a transformation from your input data to the ZAR data. We don't do any of that. So we'd say it's suitable for archiving data in that way. So a bit about the design. It's got a REST API, HTTP API at the front end, and this means that there's a client library that is written in Python, which connects to this HTTP API, and so you can use that Python to write a workflow programmatically in your own Python program. But there is also a command line client program that basically just wraps this API and provides a command line interface for you to use the NLDS. So the API is also published in OpenAPI by FastAPI, which means that it's discoverable, and there's various programs that will write interfaces for that if you wanted to write your own. That's probably only for the heavyweight developers, that kind of thing. Most JASMIN users, I would say maybe 80% of JASMIN users will use the client, the command line interface, and another 20% might use the Python library, and then developers might use the Open API. It was designed to be portable. It's installed on JASMIN at the moment, but in theory it can be installed on any multi-user system. You just need a S3 object storage, which could be on-premise, or it could be an AWS instance. And if you're using the tape backend as we do on JASMIN, you need a tape system as well that uses an XRootD protocol. Again, that's probably for the developers. So it's available to all users, not just group workspace managers or deputies, and it implements this what is referred to as CRUD, which is create, read, update, and destroy. It uses a RabbitMQ message broker, and it's open source, as you'd expect with Cedar software development. So I'm just going to skip through the technology that we use quickly. Otherwise, time will get away. So it has a full authentication layer that ET and JDMA doesn't. You use your JASMIN credentials to authenticate when you first use it. It uses something called RabbitMQ as a message brokering system, and this allows asynchronicity, parallelism of tasks, and also crucially the resending of messages that aren't acted on, lost messages. So this makes it really robust that if a message isn't acted on in a certain length of time, then RabbitMQ will send it again. And this allows us to, for example, take the system up and down, and messages just stay in the queue. And then when the system comes up again, all the messages are acted on, and your jobs into NLDS are processed. Yeah, as a topic queue routing, that's implementation details. So we're deploying this on Kubernetes via Docker with Docker containers, and that means that we have this. It's portable. In theory, it's zero downtime. We can change the config underneath. We've got a staging and deployment, so we can test in staging before we deploy it. It has a dynamic redeployment under load, so we can spin up the instances of these microservices, and it's deployed via a continuous integration system. So this is the architecture. I'm not going to go through all this. I thought it was just worth showing that as a user, you will see this top bit. You can't see my mouse, but the user authenticator, client API, system status, and the API server, and all the bit below that will be hidden. But I thought it was instructive to show that this is like the tip of the iceberg that you'll see, and that underneath is a whole raft of technology that is working to ingest and retrieve files from the NLDS. So when you ingest things, they're held in a catalog. So the idea of this is that you can add files. Files are held in what we call a holding, and you can add files to a holding at any time. So this means that if you're doing like a climate model run, and you want the files to all be in the same holding, you can iteratively add to that holding as your runs are generated by the climate model, and hold them all in the same place. And you can do that as you're computing it. So it's like adding to a batch continuously, and it will be backed up to tape as you add those to the holding. And with some clever marshalling of using tape pools and so on, we can make sure that those files in the holding are on the same tape. So the holdings are identified by label, and the only constraint is that the label has to be unique to a user. So two users can have two labels named the same, but one user can only use one label once. A new holding is created if no holding is found, but then you can add to it. There's a default label, which is a UUID. So but you can then change the names of the labels later using a metadata command. Location records where it is. It could where the file is. It could be on tape or on object store, or on both, or on neither if it's the initial transfer. But importantly here is that file paths only have to be unique within the holding, and this is obviously different to ET. So that means that you can have a holding with a file path in, and then you can have another holding with the same file path in, and that allows you to have multiple versions of the file stored, as long as each version is a different holding. So you can use it as an iterative backup. So there's some advantages of this architecture beyond using the RabbitQ. It's got security now. Everything's authorized by auth. It has cloud available data, so you can query what the URL is of a file when it's on the object store, and that allows you to then read that file across HTTPS with your object store credentials, it must be said. The data is automatically cataloged on the ingest. The data, you can add tags to the data, search the tags, and use regular expressions on labels and paths. You don't interact with tape as a user. You just put and get files from the NLDS. That is your level of interaction with it. But the backup is handled automatically, and it's highly fault tolerant. Failed transfers will restart due to the message broker. So as I said, that's the complicated architecture. From a user point of view, this is what you see. You see the client API, the user, and the authenticator, and you contact an API server. And then you need to be aware that you have a queue. So your jobs will have some lag to them, but it won't be a huge amount of lag. It's certainly not comparable to the lag you get when you're interacting with a tape. And then you've got a catalog database. The file processor, you can just think of it as from the user point of view, which puts the files into object storage, and then those files on object storage make their way to tape. So you, as a user, you can use a command line or the Python client API. You issue commands to copy the data from the disk, and by that we mean the core byte scale out, the PANFS or the pure disk systems to and then the NLDS microservices that we saw in the part of the iceberg that was below the water, that copies the data on behalf of the user. The data is cataloged and put into the catalog database. And then as a user, you can remove the data from the disk and retrieve it from the NLDS later. This is also a diversion from JDMA. JDMA allows you to migrate data, which will automatically delete the data from the disk once it has been put into JDMA. NLDS does not support that. As an administrator, that always gave me the worries that we were deleting users' data. We'd much prefer users to delete their own data. You might be able to do it as part of a workflow. NLDS provides a method for you to check the status of your jobs, so you can poll it and then remove the data as part of your workflow. So I've gone through the catalog a bit, but the holdings, as I mentioned earlier, a collection of files, transactions. So every time you say put some data or get some data, oh no, every time you say put some data onto the NLDS, it creates a transaction. And so a holding can contain many transactions when you're adding data iteratively to a holding. You can tag the holding with key value pairs. So you could say this is, analyze CMIP data or from a particular instrument or something. And that allows you to, and then you can search with these tags. So you could say, what are the holdings that contain the data for this instrument? And a file records the details of a single file, and then the location records where that file location is, where that file is on the object store, or the tape, or both, and the last time it was accessed. And so this is how you interact with it. So there's a command line client, which is just called NLDS, and there's a very small number of commands. There's 8 there. And so there's puts and put lists. So you put a single file on. Put list, you give it a text file, a list of files to put on the NLDS. Get and get list work in the same but reversed. You get a single file or get a list of files. So meta is where you manipulate the label and the tags on a holding. Stat is getting the status of a transaction, either a get or a put transaction. List will list a user's holdings, and you can search by a label or tag, and you can use regexes for that. And then there's find, which lists the user's files, and you can search via label or a tag or the holding ID. Like each holding also has a numeric ID, and you can also search the file path via regular expression. So there's a lot of documentation that I've written for NLDS, and there's a command line reference there. But I'll skip through these because I think that it just lets you see what the format of the command is that you use. It will be NLDS put and then user or group, but this is also read from a config file. You don't always have to put the user in the group if it's present in your config file. And then there's the options there for the various. So if you put a label in, then it will add to the to a holding with the existing label. Otherwise, if it can't find a holding with that label, then it will create a new one. Same with the holding ID. Well, no, the holding ID if it can't find, if you give it a holding ID and it can't find it, then you will get an error saying I can't find it because there's a direct mapping there. You can add tags on upload, and then you can also set a job label. So that's just when you say stat, you can name your job, so it's not just named after a UUID like it would be if you hadn't named it. So you can say, you know, CMIP data transfer 1 or something as your job label. Get works the same. It has all the same options as put, but you're getting the file rather than putting it. So list requires lists the holdings for a user and a group, and then there's a very similar set of search options there, like the holding ID, the label, and the tags again. But you can also set user time to say, I want to find all the holdings that were ingested between these 2 dates. You need to specify a flag if you're going to use regular expressions when searching a label. And you can also search by the transaction ID, which might be an advanced feature for people. But find is to find your files. So again, there's the very similar options. And then there's a couple of output options here at the bottom. Simple will return, one output per one file per line without formatting it. So that allows you to output it to a text file that you can then use with NLDS get list to get files, to get the particular files you want from the NLDS. And the URL minus URL will output the URL on the object store so that you can access it by HTTP, like as cloud data. Meta updates the metadata, so you have to specify the user and then the holding ID or the label, and then you can specify the group to search as well, and then like the new tag and new label are to change to amend the tags and change the label, and then there's del tag as well if you want to delete a tag. So I think there's quite a complex setup procedure for NLDS. It requires the configuration for your JASMIN user, the JASMIN authentication URLs and scopes and so on, and also your object store credentials. So we recognize that it's quite complicated. So we created an NLDS, and it requires a file in your home directory. So we created an NLDS init command, which will fill out most of the config file for you and fill out the parts that you would have no idea how to get, such as the JASMIN authentication scopes and so on. So once you've done an NLDS init, you have to edit it to add your default user group and your object store credentials. And we recognize even this can be quite complicated. So we've written a very comprehensive step-by-step guide to getting set up on JASMIN. And then there's also a detailed tutorial taking you through like your first data ingest and retrieval on NLDS. So we've been busy providing documentation as well. So the current status of it, it's functionally complete. There's a version 1.0 of NLDS. It's in the final stages of a beta test. It's been deployed in beta for about 3 months, and we've been fixing little bugs and adding a few user enhancements to increase its usability. We'd still, if you're a heavy data user and you haven't been involved in the beta test, we'd be interested in getting you on board even at this late stage. And NLDS is almost ready for a wider release. We're just waiting for a production tape config to be finalized, which hopefully will be on Monday. So it should be fully available in the next 2 weeks. and I recognise it's been a long time coming, so thanks for everyone's patience, and people who've been contacting me on the help desk saying, is it ready yet, for at least 2 years. So yes, thanks for the patience. So it won't stand still, though. There will be some future developments, but we're throughout 2025 and 2026. But these will be what we call non-breaking changes. Nothing that's functionally works now will stop working. We will be adding some functionality. There's such as a delete and a cancel command, and adding quarters and roles, which we will probably do a future seminar on once we roll those out. I would say that because we will be developing it, the user feedback is always welcome, because it could inform what we put into future versions, or just little usability tweaks are always welcome to hear about. So yeah, you will still require a group workspace. You will be required to be a user on a group workspace to use NLDS. So we would like to widen the use to JASMIN users who may not have a GWS. And then, as I'm sure some of you will be thinking, what's going to happen to my elastic tape and JDMA batches? Well, these will be migrated to the NLDS. So by the end of by the middle of 2026, we would hope to have all of the elastic tape and JDMA batches that JASMIN users have now migrated to the NLDS and available to be retrieved from the NLDS. And we'll be doing this on a group workspace by group workspace basis. And it's important to note that it does not require moving data. We will be transforming the records in the elastic tape and JDMA databases to the NLDS database, and then double checking that we can retrieve those files that in the records that have been transformed into the NLDS object store and then onto the disk. So once this is complete, elastic tape and JDMA will both be retired once the transfer of assets to NLDS is complete. So in summary, NLDS is a hierarchical file management system using a object storage, a disk and object storage and tape. And it's got a client API server and microservices. And in the future, it will be the sole method of interacting with tape for JASMIN group workspace users and other JASMIN users who don't have a group workspace when we add that functionality. So thanks, and I'm happy to take questions in the Q&A session. I will stop sharing and hand over to Fatima.
Hi everyone, thanks for coming to this webinar session. I'm Fatima Chami, and I'll be presenting an update on what has been going on so far about the migration, and also talk a bit about Lotus and the old Lotus shutdown plan. So I'm part of the JASMIN team and heavily involved in the support plus operation, as my Alison, she already introduced me. So I'm just going to move into the next slide. So we'll start with this presentation is split into two parts. The first part, we talk about the Rocky 9 migration, what we've done, how far have we progressed in the migrating the JASMIN services. And then I'll talk about the new batch cluster and following with some announcements. Right, the Rocky 9 migration. So I'll answer some why and what's happening, list the service that are already fully migrated and the service that are still in progress, and just remind ourselves where to get information about any updates regarding the the migration. So we migrate because we need to be policy compliant. So we need to run our infrastructure with operating systems that are fully supported, and with available security updates. And the CentOS 7 end of life was last July 2024, and then we adopted a new operating system, Rocky 9, because this has more of a longer life until 2023, almost 8 years, and it's in line with the Tier 1 and other large activities at STFC. So what happened or what's happening during the most of it is happened now, but still some bits still outstanding. So there was a lot of replacement of systems and software dependencies, also for the virtual machines, for data archive has been all migrated, updated, images. So it's a lot of components that had to be migrated in in a way that it doesn't break other services, because there was like a very complex dependency tree. And then the documentation and the user supports during this period, we had to deal with quite a high volume of help desk support, because we had the two parallel infrastructure running together, and we had to put some strain on the time and effort to respond to the users in a timely manner. And we had started changing some of the documentation, especially for the service that are fully migrated to the Rocky 9, while some documentation are still pointing to the old system. For example, Lotus at the moment, that documentation will be replaced as soon as we complete the shutdown. We provided more information on the like an initial guidance on how to use the new cluster on a separate document. We call it Rocky 9 migration notes. So what has been completed? Just list from the user-facing services. So all the login services are now in operation, and they don't have no more reverse DNS, so they can be accessible without having any IP whitelisting and so on. So easy access to JASMIN. The SAI servers, they're all now under Rocky 9. They're all migrated. The exception is that the SAI VM, they are still submitting jobs to the old Lotus cluster, and while the SAI 5.3, the physical SAI machine, are submitted to the Lotus 2. But this is it will change. It's going to change, because we're very close to the shutdown, which is going to happen in this Friday. I'll talk about it in a different slide. What has changed is the naming as well. We introduced the two character VM and PH, just to distinguish between what is a virtual machine and physical machine. And also, by knowing that it's a physical machine, we now have more resources, more cores, while it's virtual machines, the resources are limited. So if someone wants to test some multiprocessing, it's better to do it on a physical than do it on a physical, rather than doing it on a virtual machine. And we did the same in the naming for the XFAIR data transfer XFAIR. So all the standard data transfer XFAIR are virtual machines. And we have 3 now, 0, 1, 3. And the XFAIR 3 actually has a cron service available for automating some data transfers. Same happened for the NX server that support the graphic remote desktop JASMIN. So we have 3 NX servers and NX4, I think it's to follow. And there's some notes on the SSH key for compatibility that I'm going to cover that in a different slide. Not long ago, we managed to convert. We had cron submitting to the old Lotus. Now it's been completely switched over. So cron 1 is now invoking jobs on the Lotus 2. And the same applies for Silk. Now we have Silk 2 is invoking a job on Lotus 2. In addition to that, we have now 2 new collections for Globus endpoints. for transferring data, and they all have the same set of file system. They can access to the home group workspace and XFCE plus archive. And probably mounting of the scratch will be coming soon. So the user-facing services migration that is still in progress. So the GPU cluster ORCID at the moment, there's one node that has been migrated to the Rocky 9 and with this software stack of packages installed on it, and it's currently in testing, and it will show as ORCID partition, but it's not accessible at the moment. So we have invited a few users to run some tests on the node before we open it to the queue. The other service is the Mass client machine. I think this is at the time it's been provisioned or migrated to Rocky 9, but they're still awaiting some configuration changes with the Mat office for the Mass, for some connectivities set up. And the Muse machine, we have in the old cluster and the old Lotus a Mass partitions. So that Mass partition has access to a machine that can talk to the Mass repo for automating pulling data from the Mass repo. So at the moment, this machine configuration for that to communicate to Mass is still awaiting, but it's been configured, it's been migrated to Rocky 9. So this is still awaiting for that step to be completed before we open it in the new cluster. And in the new cluster, it won't be a partition to access the Muse machines. It'll be through another quality of service will be defined to access the node for automating transfer. And the task gateway. So this is so there's a machine, there's a VM now that's been provisioned, Rocky 9 VM, and we cannot do. I mean, it's still awaiting when we're going to switch over. We need some downtime to kind of switch over the taskway to the new Rocky 9 VM, which communicate to Lotus 2. So that will be there will be some announcements in due course on this. So a few notes on the NX service. The recommendation is to use this ECDSA key format to be able to connect to the NX. And so the advice is to generate a new key and upload it to the user, upload it to their JASMIN profile, and it should still work with all the Sensor 7 for those who still need to complete some jobs running on the old system. But it will be definitely working for the NX and other like apps or EDI like VS Code. So where to find all that information? So we have a status page on this website here to look at the information, and all this information on the status page can get pulled on the message of the day open logging into JASMIN. And we try constantly to update this document where we put all the services that have been migrated and those that are retired. So the second part is to talk about the new Lotus 2. So just a quick overview of Lotus 2 spec and the different partition, quality of service, and Slurm accounting, mainly to say the what and the why questions about them. So the new Lotus cluster is about 277, I think it's more 277 nodes. So in a total of 55,000 core now installed and available. And the node specs are significantly higher than what we have on the old Lotus. A new Slurm controller and database were provisioned, deployed, tested, and we installed a new version of Slurm 2411. And we think we're operating in a configureless mode on the compute nodes. We restructured the partitions, simplified them. In the old Lotus, we had like 6, 7 standard partitions. Now it's completely simplified, reduced to 3 main partitions. And we introduced the Slurm accounting per project that maps the membership to a group workspace. And we also introduced new approaches to Slurm configuration changes. And an important bit here is regarding the local temp. So there's a private local temp on the per job on the compute nodes, and compared to where it was in the old Lotus cluster. And just to add, so internally this cluster was known as Sakura, and all the file systems, home directory storage are mounted on as they are mounted on the old Lotus cluster, except for the application, for the software stack that we have moved them to a different storage for that. So this is just a table showing the hardware spec. Currently the standard partitions has a pool of 265 nodes. They are quite a massive node with 192 cores in total. And they have access to, each node has 1.5 terabyte of RAM. And we have what we call a high resource nodes. We have 11 in total. And they are the same spec, but the difference is in the memory, quite a large memory per node, 6 terabytes. And has 200 gigabyte network connection. I don't want to enter into all this more kind of low-level spec or the hardware, but just to give you an idea of the size of these machines, the new machines. So coming back now to the Slurm queues or partition and the quality of service. As I said earlier, we shrink the number. We have now 3 simplified queues: partition, standard, high res, and debug. And to one important change that we made this time, each queue has its own pool of compute nodes. We don't have any compute node floating between the different queues that we had in the old Lotus. So here, standard can see just its own pool of queues of nodes, high res, and the debug. And so the partitions will have access to different QoS. So QoS by definition is how we define the resources limits. So we can define any number of QoS that we want, and then we can assign those QoSs to those partitions. So when a job is submitted to those partitions, it has to have a quality of service specified at submission plus an account. So these are the 2 new options that are, well, it's not a new option, new ways of accessing the cluster. The access is controlled by membership to an account and by specifying the quality of service. Because by specifying the quality of service, the job will be set a limit. Without that, access to the queue is rejected. And we have put the rejection, why we wanted the rejection also. This is a new change. In the past, we didn't have any deny or limits. Job will still be submitted, but will end pending forever because the resources are not there. While here, any submission that doesn't fit the window of the resources limit within that particular quality of service, Slurm will just reject the job and will just tell that it's outside the policy and so on. Maybe there will be another follow-on to discuss that more in detail about the quality of service and the limits. So what we have, how we define those quality of services or those policies. So the 3 main parameters for this is the priority, the maximum CPUs per job, and the max hold time. So we tried to make the transition from the old system as easy as possible. So we kind of configured the standard and the short and long to match more of the max work time, which is 24 hours, 4 hours, 5 days. And we made a standard as the the short quality of service the highest, because this short has a high turnaround of jobs. So a user can have many jobs run and completed within 24 hours. So we increase priority because it has small, very short max hold time. The high res, we at the moment we are still reviewing or assessing the high res. So we would just, it won't be possibly in the future, this high-res will be considered as a bespoke resource for particular high job requirements. But at the moment, all the accounts have access to the high-res partition at the moment, and it has so it has a maximum runtime of 2 days. And we introduced within the high res, there's a high res and there's another mem res. Mem res is quite new. I didn't mention it here. It's just to kind of separate those from those who are running just single core high mem job, and from those who are running high core plus high mem job. But as I said, high res at the moment, it is still being reassessed, and yeah, updates will be posted in the relevant places in the Rookie and I migration and through announcements. And then we have a debug. So a debug allows any workflow to be tested, and it's the best place to submit jobs to when someone get code that they don't know how the code will run and how it consumes the resources. So it's better to run it on the debug. And as I said, those debug are a set of nodes that are completely confined from the other partitions. How are we doing with time? It needs 10 minutes. Okay, cool. Now moving to the Slurm accounting. So the accounts have been created in a hierarchy fashion here, with most of the parents' account based on the existing JASMIN consortia, and the remaining parents' account are for system or admin. So, and we have provided a command called user account, which is just a wrapper to the Slurm account ACCT-MGR that query the database. So it will show the user which account they belong to and which quality of services those accounts have access to. And for those users who don't belong, they don't have a membership of a group workspace, they will be added in an account called No Project for that. But it's not something that we want to continue to maintain. But we want everyone in the future. Maybe that will change. They might need to join an existing group workspace. But this is for now. They will be in that project, in that Slurm account called No Project. So why did we adopt the Slurm accounting? First of all, it's to give you a better idea on the compute users per project, and it will improve the scheduling and the fair share. Historically, and until now on the old cluster, we have just one single account, which is a default, and there's no need to specify the default JASMIN account, and it is oversubscribed. So we created different accounts to be able to improve the scheduling and the fair share. Just going back to the old cluster, the only accounts, the two different accounts that we have an account for ORCID and an account for the short 4-hour queue, because that partition has the nodes are confined. But we're moving completely from the single default JASMIN account that we had in the past. So everything is going to be accounted for per project, and also per project at this time. So what has changed in the software stack? So we have a new version of JASB, JASR, no Anaconda on it. And we won't be supporting all versions. And we started first with IDL, not just because we decided at the time, but because of incompatibility issue. So IDL 8.991 is supported, available on the new system, Lotus site machines. The compiler that we support at the moment is the Intel One API via the module environments, and GNU or GNU G4tron compiler is available via JASB environments. We dropped OpenAPI support. We're supporting Intel One API because that comes with the compiler, and it's recommended to have this MPR for performance, better performance. The other MPI implementation that can be used by the users is available via JASB, is the MPitch. And it's been tested for intranode MPI communication. So if someone wants to run a job within a single node and it has an MPI job within a single node and they prefer to use MPitch, so that should be, it's been tested, so that's possible. And also we have changed the location of where the software stack resides. And the NAG library is no longer supported on JASMIN. We didn't see any evidence of usage. The user base was very low, just a handful of people. So we're not supporting this on the new system. Other software has been installed. There has been, we had through our engagement with the user, need for NVIDIA toolkits for the NVIDIA compiler for some CUDA codes. So NVHPC toolkit is now installed on the GPU node that is being tested. Also updated and installed the CUDA driver, the NECL library for better MPR communication and singularity. Just a quick review of past issues. Just so we had a PFS, no space left on device, that was resolved. One instance of slow control a few instances of slow control hanging, that was resolved. That was just a setting that we needed to tune. And we had frequent sci-fi, the physical machine, when we opened them all for Lotus 2 crashes, and so we have enforced at the moment to C group the memory and CPU limits, but in the we're waiting for the new Arbiter tool monitor utility to be available, so we can install that in due course. And due to excessive usage of the scratch disk and affecting other users' job, which resulting in failure. Now the disk quota of 100 terabyte is applied to all users. So some news on the Lotus old clusters. So at the moment, 192 Intel nodes were retired, and the shutdown plan is that the standard queue would be closed this Friday. So no submission, but user will be able to monitor their job and query the old Slurm database until morning of the 31st of March, which is Monday. So on Monday, the Psi VMs will be shut down for configuration changes, so they'll be able to submit to Lotus 2. So expect a 2-hour outage on this. Well, coming to the end of the presentation, just a couple of announcements about event that we gonna plan to host. So the JASMIN User Conference 2025 is now being planned to take place at Harwell campus on the 10th and 11th of June. So please save the dates on your calendars. Those who they haven't been to the previous conferences, they can look at the previous conference, which was held in Harwell in November, JASMIN 23. The contents of the talks and the recording still is available online. And we are also working and supporting the we are consider JASMIN as the UK node to support the global WCRP hackathon event that is happening in Oxford first week of May. And then thank you for your attention.